Okay, so as you're getting your notes out and ready, I'm just going to discuss real quickly what we covered yesterday in class. Again, the video is loaded onto Google Classroom. If you need to rewatch it, it's always there. But yesterday we talked about the rules for adding and subtracting when there are positives and negatives involved, our integers. So remember we said we never, ever, ever subtract. Instead, we do the additive inverse. We change subtraction into addition by keeping the first value, changing to addition, and then changing to the inverse or the opposite for your second term. And once we've got it changed into addition, we follow our two addition rules. If it's the same sign, you add the bases together and keep the sign. If they were different signs, you subtract your highest base minus your lowest base, and then you keep the sign of whatever your highest base was. So if your highest base was positive, your answer is positive. If your highest base was negative, then your answer would be negative. So we just went through those rules. We looked at what it would be if we had word problems, identifying positive and negative integers by keywords like above or below, and identifying operational terms like difference means to subtract, rows meant to add. There's all sorts of different operational terms for addition and subtraction. So we did a couple of examples of those. So where we're going to continue is another format of showing how to add or subtract integers. So we followed the rules. Now let's look at a couple of visual representations. So the first visual representation that we're going to focus on is using counters, positive and negative counters. So what I'm going to do is I'm going to allow my pink to represent my negative, and my green is going to represent my positive. Pinks are going to represent my negatives, greens are going to represent my positives. So what I have here is I have just a bunch of positives and negatives written. I want to showcase what the numerical expression or problem would be, addition problem, and then what would the solution look like. So for my first problem, my first term is represented by that first column, which is a bunch of negatives. In fact, I've got 1, 2, 3, 4, 5, 6, 7, 8 negatives. So when I'm writing out my numerical expression, I'm going to write down that I have a negative 8. Now when we utilize, Camille, when we utilize our counters, we're showcasing addition. So we're showing how we are taking negative and positive counters and adding them together. So I know I'm starting with a negative 8, and then I'm going to add a positive 6. 1, 2, 3, 4, 5, 6. So I'm adding a positive 6 for those counters. So this is my numerical expression, negative 8 plus 6. Now, when we are working these problems out, we talked about it yesterday and the day before, you have a thing called zero pairs, where a positive and a negative can go ahead and cancel each other out because they would combine to create a 0. So right here, this cluster of positives and negatives, how many positives did I just circle? 6. How many negatives did I circle? 6. So a positive 6 and a negative 6 are 0 pairs. If they are 0 pairs, they've just canceled each other out completely. They've zeroed each other out because they are opposites of each other. So what am I left with here? 2 negatives. So that means when I add a negative 8 and a positive 6 together, it's going to come out to a negative 2 that remains. So this is the solution. The solution is not just an answer, but it's the expression that I identified and the answer that it comes out to. So when you are working on a test, it could potentially be that they give you the counters. You have to correctly identify the numerical expression and solution. Or they might give you the numerical expression and you have to correctly pair it with the counters. So there's two different ways that it could go about. Okay, let's go ahead and continue on to problem number 2. So for problem number 2, again, we want to identify the first term that would exist in our numerical expression. So the first term is that first column. How many negatives do we see in that first column? 4. So that means that our first term is going to be a -4. Again, when we have the counters modeled here, it is modeling an addition problem, so I'm going to put a plus sign. And now I have to identify my second value. What is my second value?
7.
Positive or negative? Positive. Okay, so it's a +7. 1, 2, 3, 4, 5, 6, 7. So I'm going to put down it's -4 plus 7. Okay, now the second thing that I need to do, now that I've identified my terms, I need to identify if I have any 0 pairs. Do I have any 0 pairs in this problem?
Yes.
How many do I have, Aisha? 4. I have 4 0 pairs, right? I have 4 negatives that can be canceled out with 4 positives. So I can go ahead and circle those and cross them off. And what's remaining as my answer? +3. Very good. So this would be equal to a +3, and that would be my solution. Not just the 3, but the statement as well, that -4 plus 7 is part of my solution. Okay, so problem number 3. Let's go ahead and identify our first term. What is our first term for problem number 3? -5. Good. We have 1, 2, 3, 4, 5 negatives. So we've got a -5. Plus, what is my second term? -2. Our second term has negatives as well. It's a -2. Okay, do I have any 0 pairs? Remember, a 0 pair has to be a negative and it's positive. So do we have any positives up here? So can we have any 0 pairs? No. So there's nothing that we can zero out, nothing that we can cross off. So that means our final answer is just going to be what? -7. We have a total of 7 negatives here. -7. Okay, sometimes you don't have any 0 pairs. Remember, a 0 pair can only be created if you have a positive and a negative that can cancel each other out. Maybe it might be 1 positive and negative. Maybe it might be 4 positives and negatives, or 6 positives and negatives. And then what's remaining that has not been canceled is what would be your answer or your value. Are there any questions about the counters? Okay, let's go ahead and gravitate to our last page, which is showcasing our third method, and that is using a number line. So a number line is also a tool to showcase modeling of adding or subtracting for integers. Now remember, we don't actually subtract in a problem, we really add. So if you ever see subtraction, you want to convert it into addition first by doing your additive inverse before you try modeling it on your number line. Now, negative values and positive values move in different directions when it comes to the number line. Who thinks they can raise their hand and tell me what direction do you think negative values will move? Do you think that they're going to move to the left, or do you think that they're going to move to the right? Angel? Left. Very good. Negative is going to cause you to move left. Negative moves left, and positive moves right. Negative moves to the left, positive moves to the right. Now, when we are graphing, there are 3 steps to graphing. Our very first step is just to start at 0. You always want to start at 0 when you are getting ready to graph. So since 0 is neither positive or negative, I'm going to put it in blue as my neutral color. Now my second step is when we get to the 0, we're going to look at our first value, and it's going to tell us the direction and the number of units that we need to move. So my first value is a -6. That's a negative. I'm going to go ahead and put it in pink. And what direction am I going to move again since it's negative?
Left.
To the left. And how many units am I going to move? 6 units. So my step 2 in this case is going to be in pink because I'm dealing with a negative. So I'm going to move 6 units to the left. So starting at the 0, I'm going to move 6 units to the left. That's 1, 2, 3, 4, 5, 6. And I will stop right there. So I'm going to make another little wall. I'm making an arrow so that I can show whoever's looking at my problem that starting at 0, I'm now going in the left-hand direction to get to my first term. Now from my first term, from the -6, I'm now going to add 2. So is that going to move to the left or to the right? To the right. So step 3, I'm going to move 2 units to the right. Am I starting at 0 or starting at -6? Starting at -6. So from the -6, I'm now going to move 2 units to the right. 1, 2. And I'm going to put a star right here because that's my stopping point. So what is my answer? -4. If we look down, the answer is -4. Okay? So that means -6 plus 2 is equal to -4. We want to make sure we understand what does the model look like and what is the solution going to give us. So there's different ways that this question could be posed to you. It could be posed in the way that I just showed you. I have -6 plus 2. I want you to model it on the number line and then tell me the solution. Or it could be modeled on the number line already for you, and you have to write down what was the problem and what was the solution. So those are different ways that they could showcase your skills using your number line. Okay, let's take a look at the second problem. Again, my very first step is always going to be to start where? At 0. So my first step, step 1, we're going to start at 0. Okay, who can tell me what color do you think I want to use to show my second step? Do I want pink or green? Brian? Why green? Because I'm moving to the right, which was positive. Okay, so my next move is to focus on that first term. That first term happens to be a positive value, so I'm going to use green to showcase that. I'm going to move 3 units to the right. So I'm going to go 1, 2, 3 units to the right. Okay, Now what do I need to do? Angel? Very good. We're going to use my pink because we're dealing with a negative now, and we're going to move 5 units to the left. So we're going to move 5 units to the left from the 3, not from the 0. We're now at the 3, and from that position, we'll go 5 units to the left, and that's going to have us stopping at the -2. So the -2 is going to be our solution. So 3 plus -5 is equal to -2. Okay, if we look at problem 3. Problem 3, we have absolute value of -3 plus -7. What do you think we need to do before we can start graphing? Think through it. I want you to turn and talk to a neighbor. What do you think? Tell somebody what you think you should probably do first before you actually start graphing. We've got absolute value of -3 plus the -7. Turn and talk. All right, so Guadalupe, what did we have to do first? Yep, you've got to find that absolute value first, because when we're plotting, we plot for positives and negatives, not for absolute values. So we have to identify what the absolute value is equal to first before we can start plotting. What is the absolute value of -3, Gal? 3. So I'm going to rewrite my problem here. I know absolute value of -3 is 3, and then I still have a plus -7. So now I can go ahead and start graphing. Again, my very first step is to start at 0. So we're going to start at 0. From there, we're now going to move in what direction, guys? To the right. That +3 is going to have us moving to the right. So we're going to move 3 units to the right. That's going to be 1, 2, 3, and gets us to that +3. From there, we're then going to move 7 units to the left because we're dealing with a negative. We're going to move 7 units to the left because we are dealing with a -7. Again, we're starting at the 3 and moving to the left 7 units. So 1, 2, 3, 4, 5, 6, 7, and it ends up at -4. So there's our solution. So those are different ways to be able to utilize your tools. You've got counters, you've got rules, and you've got number lines to be able to show you how to solve all of the same exact problems. Okay? So what you're going to be doing right now is you're going to log on to Google Classroom, and there is a quizzes that you're going to be doing. So go ahead and get your computers open, and I'll get the quiz loaded.